Welcome. Hello. Welcome to those of you in the room and those of you joining us virtually. My name is Patty Mabry. I'm the Executive Director for the Indiana University Network Science Institute. Welcome to Meet the IUNI Research Scientists. It's a guessing game. No, it's not. I'm just kidding. Okay, I'm just trying to wake you up. We have with us our Scientific Director, Bernice Pesco-Solito over here, for those of you who don't know her. We have three other co-scientific directors who are not here currently, but today we're actually here to talk about the research scientists. But before that, let me just give you a brief preview of things to come. We are having another event on March 26th. It will be a network science talk with Rika Albert. She's a Penn State University physicist. I believe she will talk about scale-free networks, but not 100% certain. We also have on March 28th, Paul Macklin will be talking about cancer and networks, and I think biological networks. And that will be March 28th, I think, at 2 o'clock. See our website for full details on all of these. And Luis Amaral will be here on April the 9th. So those are just a few of the things to come. Today's group of individuals, they will be talking about themselves, so I didn't feel the need for a prolonged introduction of each one. But here's some things that you might want to keep in mind when listening to these presentations. A core feature of our mission is to facilitate interdisciplinary networks research. And one of the most impactful ways that we do this is through the work of our research scientists. And like the areas of network research itself, our research scientists represent a wide range of disciplines, from the social sciences of anthropology, sociology, and communications to computer scientists and mathematics. Sorry, I just accidentally put my timer on for the other people before it's time. To computer science and mathematics. We're so glad you showed up to meet our research scientists, Erin, Giovanni, Xiaoran, Alice, Hank, and Kate. And I think you'll find their work fascinating, and I believe it will inspire you to consider how your field might benefit from future collaborations with them. Please hold your questions to the end, and without further ado, we'll start with Giovanni via webcast.
Hello everyone, my name is Giovanni Luca Ciampaglia. I'm a research scientist at Indiana University. I'm going to talk today about three projects in my research at IUNI. The first one is about mining knowledge graphs. The second one is an example of work that I'm doing in the area of social media analytics and data science. And the third one, I want to talk a little briefly about our work in socio-technical biases and information ecosystems. All right, moving to the next slide. The Mining Knowledge Graphs project is about building computational tools that could help journalists and fact-checkers cope with the amount of misinformation that's happening in the internet. And our approach is a graph data mining approach. We're interested in using open resources like the Wikipedia knowledge graph to automate certain aspects of fact-checking. The current approaches are based are very similar to knowledge-based construction approaches, and are mostly predicated on random walks over knowledge graphs. Our approach here is slightly different. We're interested in looking at network flows, and our tool is called Knowledge Stream. Here I'm showing, for example, one quick example of the output of the tool when a fact checker is asking the connections between all the knowledge in a certain sense about the connection between Berkshire Hathaway and Warren Buffett. We do perform analogical reasoning because, of course, knowledge networks are instances of semantic networks, and we do so using line graphs. A very quick idea explained at the top in the sequence of three examples at the top of the slide. So this project is in collaboration with Filippo Menzer, Alessandro Flammini, and Prashant Chirakar, who now is at Amazon. So in the next slide, I'm going to move instead to talking about an example of a project in the area of social media analytics and data science. And in this area, this is in particular about the social game streaming platform Twitch. So Twitch is a very popular platform that lets people play video games, stream their match and be watched by large crowds. And so these crowds attract very big numbers of people, of viewers, and one interesting feature is that people can have conversations. So our question here is it possible that as the size of these crowds get larger and larger, somehow the quality of the overall conversation is affected by the size? And our hypothesis is that in a certain sense, what's happening here is the problem of information overload, which is a problem that's affecting many of us that are using social media. We're in the main graph I'm showing here on the right. I'm showing that as the increase in information load, which we measure in terms of the number of messages in the chat that you can see instead on the left, increases, the output per capita reaches first a maximum and then decreases. At the same time, if you look at the other two plots, the smaller plots above, you can see the information content of each message decreases and the length of each message decreases as well, which suggests in a certain sense the information, the load of information at the cognitive level is creating at the group level a degradation in the quality of the conversation. All right, so the next slide is instead about our work in trying to understand and develop countermeasures about socio-technical biases in information ecosystems. This work again connects very much with our interest in the spread of misinformation on social media. You've seen probably a lot of instances of misinformation, sometimes intentional, sometimes unintentional. One example that I'm showing here is one of the divisive ads shared by the House Intelligence Committee on Facebook. Something that we're discovering using our systems Oxy and Bodometer is that social bots are really effective at spreading misinformation and targeting individuals. Here I'm plotting, for example, the results of our social bot detection tool, showing that when you look at very active Twitter users, you tend to see higher incidence of social bots. So these tools that I just mentioned, Oxy and Bodometer, are part of our suite of social media analytics tool, which are detailed here in this next slide, which is called the Observatory on Social Media, or in short, we call it Awesome. It contains several tools that I encourage you to check out. So thank you for your attention and have a good day. Goodbye.
Can you hear me? No. Yes? Fantastic. Okay. Good afternoon. My research aims to integrate health communication, social networks, and technology to reach underserved populations with effective information and then connect them to health services and solutions. My background is in public health, health communication, and social epidemiology. During my master's in public health and my doctoral schooling, I was trained in a Center of Excellence for Cancer Communication Research funded by the National Cancer Institute. And there we focused on developing communication materials and interventions for low-income racial and ethnic minority populations in St. Louis. My first network study that I did in my dissertation was to collect egocentric networks from 400 very low-income, underserved callers to a social service hotline in Missouri. The goal was to understand how networks influenced what they knew about the then just passed 2010 Affordable Care Act, and how the networks influenced their access to information about that as well. And then I continued looking at egocentric networks in underserved populations at the University of Kentucky as an assistant professor there. And I focused on the cancer communication and social communication networks of rural Appalachian women as part of the Building Interdisciplinary Research Careers in Women's Health program. The first of two project examples that I'm going to talk about today is connecting Appalachians to lung cancer screening. So Kentucky has the highest rate of lung cancer mortality in the country. And in these eastern counties, of Appalachian Kentucky, the rates can be twice as high as the national average there for lung cancer death. Appalachia is unique in that it is often socially, geographically, and technologically isolated from other parts of the country. And it's made up often of these very tight-knit communities that may primarily feature kin networks. And there are some connections to the world outside Appalachia, but there's a lot of concentrated information and resource sharing within those networks. And one of the things that we see is that lung cancer carries a great stigma and a lot of fatalism. And so people think if they're diagnosed with lung cancer, they're gonna die. But in the past few years, we can now recommend lung cancer screening with a low dose CT to certain eligible individuals that can reduce lung cancer mortality by about 20%. So this project aims to see how are these unique networks influencing people's acceptance of lung cancer screening in Appalachian Kentucky. And this will hopefully go into the field around this summer. How am I going to take it to the field? Well, we'll talk about another project that I've been working on. So how many people here have collected network survey data from human beings? How was that for you? Yes, that is the usual response I get is, ugh. It can be really tedious and painful to collect network data on both the researcher and the user, but this is so important, right? So for the past 5 years or so, I've been working on network data collection software. My colleague, Dr. Jesse Fagan, and I created a program called OpenEddy, and now that I'm here at IUNI, the IUNI IT team and I are working on a new version that is easy and engaging and efficient network software called ENSO. The software is visually driven so that it's easy to use and understand for people with lower literacy or low experience with technology. The playful design will keep people engaged through network research and interventions. When we used it with the rural Appalachian women, they said it was fun, like playing a game. We want ENSO to be the gold standard in digital network data collection software. So we will develop and test methods to include within ENSO, and we'll also test it against our other gold standards of network data collection. And what's very important to me is that we also devise good visualization and user interface for network visualization feedback in order to use it for interventions, sociometric and egocentric network interventions with visualization. It's a lot of words to get out there. So because my background is in public health and in social network sciences, and both of those are inherently very multidisciplinary fields, I have a broad set of skills and methods to bring to IUNI. I have a lot of experience in survey and intervention, design, development, implementation, and analysis. My health communication background provides me with skills in the design and development of materials, particularly for non-mainstream populations, racial and ethnic minorities, rural Appalachian populations. While I do both sociocentric and egocentric research, I primarily focus on egocentric network methods and analysis. And I'd like to move into ego network interventions more. And all of my background, as well as a good working relationship throughout my training into the present with the Health Communication Informatics and Research branch of the National Cancer Institute, have given me a skill set to help develop connected health tools that integrate all these different areas of my research in interventions, which leads me to talk about the future directions. We have a great opportunity right now to use technology to bridge the literacy gap. And by building visual and audio-based tools to reach individuals with lower literacy and technology literacy, we can engage people in research and intervention science with easy to use understand tools. So I plan on continuing to develop ENSO to do this. Again, we want ENSO to be the gold standard in digital network data collection. So we'll continue to develop and test methods here. But my greatest passion is in developing network-based intervention tools to help track network changes over the diagnosis, treatment, and survivorship phases of cancer and other chronic diseases. The goal is to identify changes in networks when they occur that might require an intervention, and then to identify and implement evidence-based interventions in a timely manner to meet those needs. I envision this as a way of providing social prescriptions, like we would provide a medical prescription or a treatment. And I imagine that this can disrupt the current care paradigm in a way that will really empower patients, improve the provision of care for healthcare providers who know that social needs and resources are important, but may not have the tools to address those, and shift that care paradigm. So I'm looking for collaborations within these areas, and I'm happy to talk more about this after the talks, the reception. Thank you.
Can you hear me now? Yes? Okay. Just to give you a little bit of background about where I come from, I have a bachelor's and master's in plant sciences, specializing in plant taxonomy and systematics, which is a little bit strange and sort of a circuitous way for me to get to network science. But if you know anything about sort of matrix-based approaches to understanding structure, the through line makes a little bit more sense. So I went to the University of Georgia. My project for my master's was a collection of plants used by the Gullah, who are the descendants of the slaves that live on the Sea Islands. I studied how they used the plants around them for food, medicine, spices, and so on and so forth. So it was sort of my first foray into anthropology. Following that, I got a PhD in anthropology from the University of Florida, specializing in qualitative and quantitative methods of social science research, with a specialization in the Francophone Caribbean, particularly in Haiti. So I'm fluent in Haitian Creole. I can both read and write it, which is pretty useful. I still get called on to do translations every once in a while for things, which is kind of fun. And it sort of started my interest in international development and international health. I ended up doing my dissertation, though, on collaboration among international development organizations in Washington, D.C. I don't know if you know much about how food aid works, but there are only 16 or 17 partners that are allowed to provide food aid around the world. And they have to compete for grants, but they have to collaborate on policy development. And so I did a qualitative and quantitative sort of ethnographic study of how they managed to balance the sort of competing pressures of competition and collaboration in an attempt to be more effective at delivering international food aid. It was really fascinating. If you know anything about how all that stuff works and how they all interact with USAID, it's like a soap opera every day. Timely, given that we don't have a government right now. But after I finished my work in Washington and got my PhD in 2003, I did a postdoc at T32 in quantitative psychology at Urbana-Champaign. I did that for 2 years, specializing in social network analysis, particularly in sort of, at that point, the very early statistical models. Like, they hadn't even had the first Siena workshop by the time I started this T32. So I did that. Worked there for 2 years, and then for 2 years after that, worked at the National Center for Supercomputing Applications in their social science department with Noshir Contractor in their Science of Networks and Communities research group, trying to find ways to take what we know about network theory and methods to build tools that facilitated big research, and then also trying to find ways to sort of take the big problems that we were hearing from big research and find ways to sort of facilitate network-based solutions to that. It was really, really awesome. From there, I went on to the RAND Corporation, and I was at the RAND Corporation working in primarily in their health unit for 10 years, While I was there, I became the director of the very first research methods center that they had there, the Center for Applied Network Analysis and System Science. And I led that group until I came here in September. So just sort of quick history of my background. In terms of my skills and my methodological focus, substantively, I work on the design and implementation of both complete and personal network studies. And I have done these kinds of studies with a large number of hard-to-reach populations. There are studies of homeless youth, homeless women, and homeless men in Los Angeles, with some proposed studies of homeless youth in San Francisco. Adolescents, mostly kids in high school, but also kids that are slightly younger. So like 6th through 8th graders. I did some studies with younger sort of middle school age kids too. In that context, we're looking at initiation of sexual activity, drinking, smoking, and so on and so forth. With the hard to reach populations like the homeless and young MSM of color, it's generally about risk behaviors associated with HIV, most of my research. So there's an allied syndrome that goes along with that has to do with all kinds of other risk behaviors. Those were sort of the outcomes we were looking at there. And then these days, most of my ongoing work that's not here at Indiana is international HIV-related research. So I have ongoing projects in the Middle East, in Beirut, looking at HIV prevention among MSM. Beirut is considered one of the most liberal countries in the Middle East, and even there, it's very difficult for men to access sexual health education. And so we are doing a randomized control trial looking at a peer-based sexual health education process. I'm on 5 minutes already. Wow. Okay. So I also, like Kate, work on the development of software for collecting, analyzing, and visualizing network data, and work on statistical methods for social network analysis, mostly about missing data. So really quickly then, my big project here is the precision medicine to population health study. There are sort of 4 pillars. We're sort of wordsmithing what the major goals of the study are. The first one is to give a voice to the citizens of Indiana regarding future directions in medical research. We also, when we collect this data, want to link social network features to health-related attitudes and behaviors, biomarkers and biometrics and demographics. For a representative sample of the state. We want to develop infrastructure for future behavioral and clinical research. So we want this to be a foundation for other people to be doing subsequent research with. And we want to facilitate collaboration with focused PHI partners up in India at the medical school to help them get information on, say, more representative samples that they can use to compare to the sort of special populations that they're looking at. Another project, really quickly, that I'm looking at, this is an R34 funded by the National Institutes of Mental Health. We're going to use medical claims data to infer physician networks associated with shared patients. And then we're going to do a bunch of analysis on that network to assess what is hindering physicians from prescribing pre-exposure prophylaxis for people who present as a high-risk individual. Right? So you could imagine that there could be some geographic issues, there could be some sociocultural issues, there could also be issues associated with particular networks, people's sort of political leanings. We're going to use this national data set to come up with a series of suggested policy changes, and then we're going to also simulate what would happen if we made those policy changes on the networks. I can talk to you guys about the future directions after everybody else has a chance to go. Most of them have to do with applying network. Oh, I'm allowed to finish? Okay. So we're looking at testing readiness and attitudes to prep for African American, Latina, and trans women in Reno. That's an ongoing project. We have a randomized control trial of a peer-based sexual health intervention, like I said, in Beirut. We have another randomized control trial of a network-based community change agent intervention among HIV-positive Ugandans. We're assessing informant accuracy and doing some informant accuracy research for personal network studies. We have information that we're doing that in Reno as well as in Botswana, which will be really cool. we have these people bringing in pairs of individuals, and we have those pairs reporting on each other so we can assess how accurate these people are. Because if anybody has done this before, you know that chasing alters down in personal networks is really difficult and expensive. And if we don't need to do it to assure accuracy, and we can assume that it varies according to some other characteristics, and we can modify that, that'll be great. And I'm also putting in a proposal to look at the uptake of new opiate treatment modalities among physicians, particularly like Suboxone and Naloxone. It's basically the equivalent of the R34, but instead of looking at PrEP, we're looking at opiate treatment. And the rest of it, I think, is mostly just all related to HIV type research, HIV prevention and PrEP readiness, so on and so forth. So I'm sorry that I went over time. I didn't think I was going to, but thank you so much for listening.
Dream is to be a game show host, so this is really working for me. Perfect. Oh, whoops. Yes, please. I'm Erin Pullen. I'm a research scientist here at IUNI. I started about 2.5 years ago or so. My background is in anthropology, like Hank, and sociology. So in 2008, I got my undergraduate degree. I got my undergraduate degree in anthropology from Michigan State, and I decided to go into studying sociology at the University of Kentucky. I was lucky enough to be paired with Bria Perry while there, and she's the one who sort of got me interested in networks. And so my 2014 dissertation, you can see, is testing the network episode model, which is, of course, Bernice Pescasolido's theory. And I got to present that talk in front of her, which was very nerve-wracking. But that's sort of where I really got my interest in networks, was when I was at the University of Kentucky, working with Bria, and then also taking courses at the Link Center there, if any of you are familiar. So that was my sort of first work in egocentric network research. So my background, I have both qualitative and quantitative skills, although I have not really used my qualitative research skills much for egocentric network research, and that's something I'd like to do in the future. So I'm trained in ethnography. I've done in-depth interviews, semi-structured interviews, focus groups, things like that in the past. And I've also used in vivo software, but my quantitative skills are really what I've been using here in my job as a research scientist. I do egocentric network methods, obviously, everything from study design, so the kinds of research questions that you can ask with this method, to implementing that. So you have an idea, you know you want egocentric networks in it, you just don't know how to put it in there. Doing that, and then also the analysis and managing the data. Similarly, I have a lot of survey research experience. I'm trained in survey research, and I've worked on a lot of survey research studies. And so similar to egocentric network research, I can do study design, implementation, and analysis of survey research studies. And then also longitudinal research. I think you've heard already a couple people mention interventions today. That's one major direction, I think, in the future of egocentric network research, is how we can use what we've learned for interventions. But another aspect I think that's really up and coming and that more people are doing is looking at network dynamics over time. And so that's something that's really important to me in the work that I do with multi-level modeling. So you, of course, have egos who may be nested in themselves over time, and then alters nested within egos. So it's a multi-level approach. And then also relevant to the work that I've been able to do here at IU is my research administration experience. So I've worked as a project director on longitudinal studies, so I have a lot of knowledge of how to design a study, how to do follow-up, how to encourage participation, which is a huge issue if you have any kind of a longitudinal project, especially one with network components, because it is very burdensome. So a lot of experience in that as well. And I'm just going to talk briefly about two of several projects that I have here at IU. The first one is Vida Sana. So this represents a collaboration with the dental school. Gerardo Malpome is the PI on this project. And also Bria Perry also works on this project in sociology. It is an R01 longitudinal study, and we have been in the field now, gosh, almost a year, which is wonderful. We're collecting data. And so what we really became interested in is, you know, when Mexican Americans particularly come to the United States from Mexico, when they immigrate here, there are sort of precipitous declines in their health the longer that they're in the United States. sort of similarly, something that we don't know a ton about are immigrant networks, what they look like, how they change with the immigration process particularly. So that's what's great about this project is we are collecting data that's going to represent 6 months before they came to the United States, their time in the United States for the first 6 months, and then also farther down the road. So we're going to be able to take a peek at their networks over time, before they left their home country, when they first came to the United States, and then later, and look at how that influences their oral health, but also their mental health. Bria Perry and I, obviously both being on this project, were able to sneak some of our questions in there regarding mental health. So that's very exciting. And just the purpose, as you can see here, is to identify the relationships between acculturation, personal network dynamics, so changes in networks, and then the diffusion of norms, resources, and evolving oral health behaviors and outcomes over time. So that's that study. And then another project that I just started recently represents a collaboration with Bryan Dodge in public health, and then Janet Arnaud, who's in the School of Medicine and at the Bellflower Clinic. What we're doing is a study to look at the egocentric social, sexual, and drug use networks of MSM, at-risk MSM in the Indianapolis area. Syphilis is a growing problem among MSM across the country, and Indianapolis actually had an outbreak, I believe in 2007, which took a while to contain. The CDC originally put out a call for research looking at egocentric networks particularly, which is unique, right? Mostly when people think about STIs, they think about whole networks. But in this case, we're doing egocentric networks, which is great. So we originally submitted to the CDC. We were not funded, but we were lucky enough to turn it around and submit to the state, and they did fund us. So we are going to be looking at 3 waves of data of MSM who are at risk, some of whom will come in and test and have syphilis, some of whom will not. And what we're really interested in is looking at the sort of risk and protective factors of these different groups so that we can tailor an intervention. Intervention is the main goal of this study. And so future directions of research. So a couple of these are projects that I'm already working on. Hank described the Precision Health Initiative. I'm working on that as well, which I didn't list on here. Pregnancy discussion networks and maternal health is something that I became interested in recently when I was approached by a colleague in sociology who has an amazing data set with egocentric network measures and all these sorts of maternal health outcomes. So I'm going to be working with her and some students on a project looking at how the personal networks of women during their pregnancy influence their experiences of pregnancy-related problems and also their outcomes after birth. Of course, oral health networks and Latino immigrant health disparities, and health disparities in general is an interest of mine. You can kind of see the common thread across my projects. I also do work in mental health recovery, and the impact of formal and informal networks. So that's another area of interest for me. This is another collaboration that I had with someone in psychology where we looked at workplace networks among human service employees. That's ongoing. And actually something that I would really like to get into that I'm not working in currently, if anyone's interested, is chronic and autoimmune disease management. So how networks influence folks who have chronic health problems that, constrain their lives, and how their networks influence their outcomes and their trajectories over time. So yeah, thank you very much. You want this or do you want that?
I can have that one.
Okay, still on? And the clicker's ready.
Hello, I'm Alicia Patania, and unlike most of the people that presented until now, my background is actually in theoretical mathematics. I did my bachelor and my master at the University of Torino, where I specialized in algebraic topology. At the end of my master, I started working for the ISI Foundation, which is also in Torino and specializes in complex systems and complex networks in particular. And I worked there for 6 months, after which I decided to go into taking a PhD in applied mathematics. And I started working on topological data analysis together with my team at the ISI Foundation. And I arrived at IUNI in the summer of 2017 a couple of months after getting my PhD from the Polytechnic of Torino. My background being so theoretical, my skills mainly are in applying algebraic topology to the analysis of data. The two main methods that I specialize in are persistent homology and cohomology, and building a topological skeleton for data. These two techniques have in common is that that the idea behind topological data analysis is that what is very important before doing any kind of statistical analysis on your data is to understand its shape. And by shape, I mean that the relationship between data points, so points that are very similar to each other, can be seen as points that are very close to each other in a space, and things that are very different from each other as very far away in the space. And if one can study this space in which they are in a mathematical way, one can direct the statistical methods in a more precise way and get more clear results out of it. I've been applying this method in the past 2 years, mainly to biomedical data, and in particular to gene expression and neuroimaging. And I've been doing the same here. A project that I've been working on for the past 6 months has been on the human lifespan. I've been studying the Nathan Klein Institute dataset, which constitutes diffusion MRI adjacency matrices for 622 participants whose age ranges between 7 and 85 years old. I consider each matrix as a point in a high-dimensional vector space. And using the mapper algorithm, I was able to construct this network. As you can see in the video, in the network, the younger participants are at one far edge of the network, and the older participants are at the other far end of the network. And as the participants age, they scatter across the network to then localize again at the other farther end. We have been using this structure, the structure of this network, to try and localize regions of interest in the brain that have some clear dependency with brain aging. The other example that I'm bringing to you today is about ecological network. This is a project that I just started with the Dynamica Research Group at the University of Laval in Quebec City. And we are studying ecological network for 185 sites. We have concentrated for now only on bird species. And for each habitat sites, we built a co-occurrences network for the species. And what we did is to assign to each set of co-occurrency species a specific object in our data set, and studied these the data set for habitat that was untouched by humans, and habitats that are instead managed by the Canadian rangers. And as you can see in the videos, as we start adding in our network sets of species that are frequently co-occur with each other, in the natural habitat, we always find a very cohesive subset of species that tend to always co-occur with each other, whilst for the managed habitat, we have missing subsets of species, and which tend to indicate that the human presence, even if it doesn't change that much the number of species, it does change a lot which kind of species happen together. So in the future, whilst I'm here, since I just started, I wish to develop furthermore the application of these methods for biomedicine and brain data, whilst at the same time still work on developing new computational tools using my algebraic topology techniques. In particular, I started working on extending existing technique from cohomological studies to temporal network analysis.
Hello, my name is Xiaoran Yan. I think I'm the last presenter today, but certainly not the least. And oops, just got it. Okay. So I'm trained as a computer scientist, and from the very beginning, even as an undergraduate, I started working with networks. So it has been a slippery slope ever since. But as a theoretical computer scientist, I have the privilege to working with very different domain experts, including ecological networks, social networks, and now I've expanded my collaborations to brain networks, scholarly networks, and so on. So this gives a much better sort of overall summary of my methodological expertise. So I've break it down into 3 stages of doing data analysis. So when you collect data, especially if you're crawling data from networks like internet, you're inherently facing statistical biases because the way you explore the data. So we've done a couple of work on this analysis of the social lensing effect because of that. Recently, we are starting to work on a more basic challenge in data science in general, is that how do you clean the data? Because as a lot of people complain, you spend 80% of time cleaning your data before you can do any real research. So in this particular case, we're trying to figure out how can we automate, or at least semi-automate the process of doing entity resolution, which basically tells apart, are the 2 nodes in the network really the same person, or is the same 2 entities have been merged in the same node and you should really split them. So there's statistical ways to sort of resolve these issues. So once you've cleaned your data, you still need to manipulate your data into a format and shape that you're comfortable with, so that you can apply your favorite network tools. So in these, there are a couple of examples here. You can do thresholding. You throw away some supposedly unimportant noise, or you can transform the representation of your data. So that's another area that I've experienced in. The last part, data modeling, is also very important. From my perspective, a lesson I've learned over and over again is for scientific reproducibility, you cannot really actually separate these stages. It really depends on what data you have and what you're looking for as your task. Every step in this pipeline matters. It's going to affect the final outcome you're going to find out. So it's a much better approach. You think the whole problem integratively. And a major theme of my research is really to make every step precise, developing principled statistical methods that can actually tell you quantitatively what's the effect of each manipulation you down to the data. I think that's a key in making sure your science is rigorous. So here's a few examples. So here's a recent work we've done here concerning about thresholding, linear thresholding of weighted networks. So here's a little example of global airline network. In the bottom is a resulting network if you throw away 80% of the lightest weighted edges. As you can see here, you roughly preserve the major structure of the global transportation. But if you really think of it though, linear thresholding is such a naive and simple technique, and it's very dangerous because you can throw away very important edges. Although they're very light, they could be a key connecting route, right? So our study sort of really alleviated a little bit the worry that if you think about this, is that in most real-world empirical networks, they actually follow this special structure that they form core, periphery, and community structures. And these heavy edges tend just to be those important connecting edges. But there are also a lot of cases, you know, that's not the same, especially in social science, you have the weak ties, right? So as you can see here, there are different metrics of network really follows a different pattern as you're throwing away these, as you're doing your thresholding. So I think it's very important to make sure you're preserving the properties you're interested in while you're doing this. So we developed a spectral graphs measure, allow us to at least keep track of the backbone part of it. But as I said before, you should be clear of what you're doing here until you're doing this, because otherwise you're going to be basing your analysis on faulty data. The second example I'm showing here is on brain networks about models, which tells us a sort of integrative sort of perspective of how data manipulation and modeling can interact with each other. So we are studying the theoretical hypothesized communication pattern in the brain. So in one extreme, you can have this very simple model of information diffusion, random walk. You need minimal information about the global structure, but you pay the high cost of take a long time to reaching to the other side of the network. In the other extreme, you have this shortest path routing, where you know the global structure and you can beeline towards your target at the cost of you need a lot of information. So we built this mathematical framework able to interpolate between these two extremes. It is lambda parameter. As you can see here, under different communication patterns, your different parts of the brain behaves in different roles. And that's sort of an indication of your perception of the structure really changes as you change your perceived model on the network. It's interesting that we find that in the middle here, you get a sweet point where you actually pay a little bit of price and get the most of benefit out of it. So this is my last slide about future directions. So thank you, Alice, because I stolen your slides here. So on very high level, my work really concerns about sort of interaction between the interpretable graph representation and the computationally efficient data-driven representation that's getting more and more popular these days, thanks to the revolution of artificial intelligence and machine learning, deep learning industry. And my hope is by being able to close the loop, because we know a lot of ways to go from the vectors and construct networks out of it. But if we can have a very principled way of transforming network representation back into vector space, we can close the loop and hopefully being able to go back and forth and take advantage of the best of both worlds. In fact, example of this has already been done by Microsoft in their scholarly networks, where they were able to tackle this challenging problem of cleaning the data, modeling data, and actually give you very reasonable recommendations on their scholarly system, if you have a chance to check that out. So my hope is that I think there's a lot of potential in this integrative approach, and we're trying to develop now, I think, apply this to the multi-omics data here in collaboration with the medical school. Thank you for your attention.
Great. Thank you so much, all of you. Okay, so now we have time for questions. Now, are there going to be any coming in here online, or where would they be coming in from the folks who are virtually watching? Okay, so who would like to take the first crack at our research scientists? Questions? No? Well, I guess, Xiaoran, maybe you could tell us a little bit about how the multi-omics, you kind of sprinkle that out as a some kind of bait for people. They didn't take it yet, but about how this embedding, the vector embedding might be used for the multi-omics. for the Alzheimer's?
I guess I'll just say a little bit more about, because it's really early stages, because we're still discussing on the ideas. But the sort of theme here is that in the multi-omics data, you have the genomics data, you have the protein interaction, you have these different layers of that models different systems at different level, and they have different formats. Some are strings, some are actual images, and our hope is that we can using this transformation of representation, combine them into sort of a common format, and really do an integrative study of all of them, because that's sort of the being lacking in the field. Because there have been separate studies at each individual level. Our hope is we can now combine the domain knowledge of the expertise we have in the medical school and psychology department, but also we have a lot of data now collecting from each patient, and so the hope is now we can really take advantage of these resources, and the hope is that the final hope is very ambitious. They want to answer the question, what really causes Alzheimer? But I think that's going to be a long way. But hopefully, by going back and forth, we can figure out what the important sub-problem is, that, and then we try to answer each of them, making our progress towards there.
Thank you, Xiaoran. Any questions from anyone else in the room? Okay. Oh, someone online? A question from anyone online? No. Okay. Last thing I'll do is I'll ask the research scientists who presented, do any of you have something you didn't get to that you really have a burning desire to share with everyone? No? I think what that means is everybody is eyeing the food table over there. It'll be set up in a couple minutes. So for the meantime, we can talk amongst ourselves. Okay. Okay. Thank you.